Hello. Today we're going to be doing Unit 9, Lesson 5. We're going to be talking about properties of logarithmic functions. This is really a continuation of Unit 9, Lesson 4. So let's look at the different notes that I've left here. So we have the product rule, quotient rule, and power rule. And these are different ways that we will expand logarithms. Um, we have a logarithm with a base of a power, which this is very similar to what we were doing in Unit 9, Lesson 4. When you have the base to a base, it equals the exponent. And then this one, a base to a logarithmic power. Basically, if you have an exponent that matches the base, or if you have a logarithmic, which is an exponent, to the base that is the same base, then it equals whatever that big number is, the x. Uh, and here are a summary of all of them. This is a quick reference here for you. And then I have listed the common errors that students make with logarithms. And so that's just a good thing to make sure you don't do this sort of thing. All right, let's go ahead and get started on some problems. All right, so what we need to do is we need to expand. So this is log base t. Now this is multiplication. And so with multiplication, if you look at the notes that are on that first page, you'll know that multiplication means addition. So this is log base t of 8 plus log base t of y. All right. Here we have a power. When we have a power, an exponent, we kick it out to the front. So this becomes 3 times log base b of t. This is division here. With division of logs, we write it as subtraction. So this is log base t of m minus log base t of 8. And so these are using either sum, product, or difference of logs to write them all out. Most of the time, you're not going to have one that's just a one step like this. It will be a combination of them. So let's look at some more like that. All right. So here we have log base a of 6. And then that's times x, which will be plus log base a of x plus log base a of y to the 5th plus log base a of z to the 4th. And so that's writing them all out as products of multiplication, but some of these have exponents which we need to kick to the front. So this is log base a of 6 plus log base a of x. That 5 needs to be kicked out to the front, so that's 5 log base a of y plus this exponent of 4 needs to be kicked out to the front, 4 log base a of z. And now that one is complete. They expanded out. All right, let's look at the next one. So this is ln. I always like ln because you never have to worry about writing a base because the base is always e, minus ln of 3x to the 3rd y. All right. Now inside here, there's multiple multiplications. So we need to take care of that. So ln of 2 minus, I'm going to put a bracket here. So we can do ln of 3 plus ln of x to the 3rd plus ln of y. Okay, so that subtraction needs to be applied to everything. So that's ln of 2 minus ln of 3. This 3 needs to be kicked out to the front, so that's minus 3 ln x plus ln y. All right, let's look at the next one. Log base a. And here we have this square root. So if you remember with square roots, that is can be written as a half. So that's x to the 6th, p to the 5th, q to the 8th, and all of that is to the half, which we can apply that half to the 6th. So that becomes x to the 3rd over p to the 5 over 2 and q to the 4. So then we have log x to the 3rd minus log p to the 5 over 2 q to the 4. So then we can kick that 3 out. So that's 3 log x. And we're going to separate these. So that's log p to the 5 over 2 plus log q to the 4. Okay, so 3 log x minus, I'm going to distribute that minus and kick any exponents out to the front, 5 over 2 log p minus 4 log q. All right. So just take these one step at a time and then just apply the 3 rules that we did on the previous page. Okay, now we're going to work in reverse. So we're going to take what is expanded and condense it. So this is log a. Addition means multiplication, so that's 75 times 2. So this is log a of 150. Okay. Here we have exponents, so those exponents need to be put what the number in front become exponents. So we have log n of 1/2 plus log m of 3. And so then this would be log square root of n m to the 3, because that's now multiplication. And then I always like to put what is not in a radical and out in front. So log m to the 3rd square root of n. Okay. So subtraction means division. So this would be ln x squared minus 4 over x plus 2. Now I know on top is difference of squares, so that's ln of x plus 2 x minus 2 over x plus 2, which will cancel those out. So ln of x minus 2. Now you do want to put these inside parentheses so you're not writing ln of x and then minus 2. Make sure that x minus 2 is all together. All right, let's look at the next one. So we have ln of x and then minus all of this. So minus 3. And I'm going to start with this inner of ln of x minus 5 plus ln of x plus 5. So that's ln of x squared minus 25. Because that's difference of squares. Now we have a 3 out in front, which becomes an exponent. So that's ln of x minus ln of x squared minus 25 cubed. And then that minus means division, so we're going to do ln of x over x squared minus 25 cubed. All right, let's look at another one. Okay, so this is very similar to what we did in our last lesson. We have p to the p, so this is just 3. Right here, this base and this base agree, so that equals 4x. This 10 is the same as the understood 10 that's here, so this is w. These are just applying those rules on that first summary page. All right, base e and base e agree. There's that understood e there, so this is 8t. This is log base b of b to the 1/2. And since the bases agree, that simplifies to 1/2. And this 5 and this 5 agree, so that equals 8. That's all I have for you today. Happy studying.